The subject of this video is levers. We're going to first discuss what they are, define them, what they do, why do we use them, and where. What are the parts of a lever? So every lever has 3 distinct parts, and also there are 3 different types of lever or classes of lever. Okay, so a question. First of all, what is a lever? A is a flexible object that bends under force. B, a rigid object that uses a pivot to increase force. C, a machine that creates electricity. Or D, a tool used to measure weight. So the correct answer is B, right? First of all, a lever has to be rigid. If it was flexible, it wouldn't work, okay? So it's a rigid object. And here's the key. Every lever has a pivot. It uses a pivot. It relies on the pivot. The pivot is what makes the lever, okay? And what the pivot does is it increases force. So let's go into that a bit more. So a lever has 3 main parts. We just said pivot. The other word for a pivot is a fulcrum. So if you hear fulcrum, think pivot, and vice versa. They mean the same thing. Okay, so the fulcrum, it is the pivot point. Like the middle of a seesaw, okay? So if you're not familiar with levers yet, think of a seesaw in a children's playground, okay? You got 2 ends and the bit in the middle. The bit in the middle, that's what the pivot is. Pivot means everything moves around it. It doesn't move, but everything else moves around it, okay? So it says it's the point around which the lever moves, okay? So if you're ever confused about which part of a lever is the pivot, just ask yourself, what's the bit that doesn't move? The bit that doesn't move is the pivot. Okay, then you got 2 other things. You got the effort or the force, right? So again, think of the seesaw, right? On one end of the seesaw, you've got a brick or a sandwich or something. And on the other end, you sit on it yourself, right? You're going to be applying the effort or the force by the weight of your body pushing down on the seesaw, right? And that's the effort. The load will be the bit on the other end of the seesaw, the lighter object in this case. That's the thing that you're trying to move up and down, right? So you've got fulcrum, otherwise known as pivot. Effort, which is also referred to as force, which is the pushing or the pulling, the effort that you're putting in. And what you're trying to do is you're trying to move something. You're trying to move the load, whether it's up or down, left or right, forwards, backwards, whatever you're trying to move, that's the load. Fulcrum, effort, load. If you don't have one of these, it's not a lever. Okay, so what's the main benefit? Why do we use them? Right, so seesaws for fun, but in plumbing and industry engineering, they have a very important role. So the main benefit of a lever, A, it makes things heavier. B, changes the direction of force. C, it multiplies the force to move something heavy. Or D, it slows down movement. Correct answer is C. Okay, so here's the key. The reason we use the lever is that it multiplies the force. Now, what does that mean? Basically, a lever will help you move a heavy object more easily, right? You still have to apply force. You still have to put in effort, but by using the lever, it makes it easier to move the load or move the object, and we call that mechanical advantage. It multiplies your effort, right? So if you had something heavy which you couldn't lift, or maybe you could even lift it with your bare hands, using the lever allows you to lift it by using less force. So it's helpful for loads of different things in life, okay? Basically, you don't have to use as much force and you can still lift something heavy. So that's why we use a lever in the first place. Okay, now we're coming on to the different classes, the different types of levers, and we said there's 3 different types. Question, what is an example of a first-class lever? A, a wheelbarrow. B, a human arm. C, is a seesaw. Or D, a spade. Okay, the correct answer is a seesaw. Right, so let's get into the difference and how you can remember to tell the difference. So in a first-class lever, the pivot is between the effort and the load. So remember, we said every lever needs a pivot, needs an effort, needs a load. The only difference between a first, second and third class lever is basically what's in the middle, right? So in a first class lever, the pivot is between the effort and the load, which means it's in the middle. So remember I said, imagine the seesaw, the bit that doesn't move, the pivot is in the middle. The middle of the seesaw never moves. It's the sides, the ends that move. Okay, so these are some examples. You've got a seesaw, a claw hammer, float lever valve, or water pump pliers. Okay, and so the effort and load are on opposite sides. So here's a quick example. This is basically the same thing as a seesaw. Okay, except not a children's seesaw, but the principle is the same. So the fulcrum, you'll see, that's in the middle, right? So let's say this load weighs, 20 kilograms or 10 kilograms. You could still lift it, right? But by using this lever and pushing down, it makes it easier or lighter to lift that load, right? So remember, first class, fulcrum or pivot is in the middle, right? It doesn't matter what side the load or the effort's on. They can be interchangeable. Okay, now we'll come to the second class lever. So what's an example of a second class lever? A, wheelbarrow. B, human arm. C, a garden rake. Or D, a claw hammer. The correct answer is wheelbarrow. Right, so why? Remember we said all levers, they all have a pivot, they all have effort, and they all have load. Only difference between the classes is what's in the middle, right? So in the second class lever is the load that's in the middle. In the first class, it was the pivot that's in the middle, right? But now in the second class, the load is in the middle, which means you've got the pivot on one end and the effort is on the other. So the easiest example to remember for this one is the wheelbarrow. So think of a wheelbarrow here, right? You got the load, that's what you're trying to lift or what you're trying to move. Could be anything. Bricks, a sack of soil, cement, anything, right? The effort is going to come at the end, right? That's where you're applying the effort to do the lifting, okay? Which part here doesn't actually move? The bit that doesn't move when you're doing the lifting is going to be the wheel, right? So the wheel here is the fulcrum. Once you start walking with it, yes, the fulcrum moves, but just don't worry, that's not important for this bit. Just concentrate on the lifting bit. The fulcrum is at the end, right? The load now is in the middle. So first class, the pivot's in the middle. Second class, the load is in the middle. Now we come on to the third class, which is an example of a third class lever. A, water pump pliers. B, a spade. C, a crowbar. Or D, scissors. Correct answer is B, spade. Okay? So, in the third class, it's the effort that's in the middle. The effort is between the pivot and the load. So a good example is the human arm, the hoe, a garden hoe, or a spade. Spade probably the easiest one for you to remember. So if you can imagine a spade, you push your spade into the ground. Right, would you be? Because you're trying to lift some sand or some soil or something, right? Not the best picture in the world, but just try to imagine it. You're holding onto the handle or the end of the spade. That doesn't actually move, right? The effort is going to be applied in the middle. It's the hand in the middle that's going to do the lifting. So the load is going to go up. The effort, the hand that's going to move is in the middle. And in this case, your other hand which stays still, that's going to be the pivot. Okay, so to recap, a lever needs three things: a pivot or fulcrum, effort, otherwise known as force, and then you've got the load, which is what you're trying to lift. And you've got three different classes of levers. And the easiest way to remember the difference between them is what's in the middle. First class, the fulcrum in the middle. Second class, the load in the middle. And third class, the effort is in the middle.